Welcome back. Chapter 12, Section 4. We're going to do a quick little review with distributing. If you have something like this, you would multiply the 2x squared through to both parentheses. So you have 2x cubed plus 6x squared. This time, in number 2, we need to distribute the x first. So we would have 3x squared plus 7x. And then we'll distribute the negative 5, don't lose that negative, to get negative 15x plus negative 35. Now, we need to make sure we put the like terms together. So our final answer for this would be 3x squared minus 8x minus 35. You could put plus a negative, that'd be great. That's also the FOIL method. This time we're going to distribute the 3x to each of the terms. It is a trinomial, so we're going to end up with a trinomial. 3x to the third plus 6x squared plus 6x. Alright, now we're going to go through division, which is what we were doing yesterday. There's no pluses or minuses here, so you can reduce anything. 12 and 40, I know a 4 goes into both of those, so I'm going to divide each of those by 4. So in the numerator, I'll have a 3 left over, and in the denominator, I'll have a 10 left over. Now I'm going to look at my x's. I have 12 x's on the top and 5 x's on the bottom. If I wrote those out, I can literally cancel 5 of them. Now, when you subtract, or when you divide, you do subtract exponents, so I could bring this up and subtract, or I could look at this. Regardless, I have x to the 7 left in the numerator. And then if you look at your y values, I have 10 y's on top, 15 on the bottom, so I have 5 y's left on the bottom. Same method as the x's. Now, when you divide two fractions, so it's kind of like thinking about 2/3 divided by 1/2. Now, that is improper math, so we're going to actually get that 1/2 off the denominator by multiplying by it. So that means this is gone. So when I'm looking at that, I'm going to rewrite this as 2/3 times 2/1. Same thing as I have right here. When you're multiplying, the top multiplies with the top, the bottom with the bottom. So I'm left with 4/3. You could write that as 1 1/3 or 4/3. Either answer is good. Right next door, number 6. Basically, whenever you have division, you're going to change it to multiplication and flip the fraction behind the initial division sign. You're flipping the fraction because you're getting that thing off of the denominator. So my numerator here would be 9. My denominator would be 55. Done. If you can reduce, you need to. No decimals though. Alright, 2/5. Change it to multiplication, and now I have 15/7. I could go ahead and multiply, but I do notice that 15 and 5 both have a 5 in common. So I could make that a 3 and that a 1 first. You could do that after you multiply across, or you could do that right away. Regardless, your final answer will be 6/7. And last on this page, multiply by 16/9. Anything on top reduces with anything on the bottom. So I'm going to reduce the 3 and the 9 to a 1 and a 3. And then I'm going to reduce the 16 and a 4 to a 4 and a 1. So we are left with 1 times 4 on top, 1 times 3 on the bottom, 4/3, 1 1/3 is another great answer. On with the lesson. Alright, so we're going to simplify this. The first step in simplifying is to factor everything all the way. I'm going to take a negative 4 out because I want a c minus 4 down there. And if I take a negative 4 out, that's exactly what I have left over. I'm going to kind of cross this off so I don't look at it anymore because I don't want to get confused. I can then cancel my c minus 4s, and I can also cancel my 5 and my 45 and make that a 9 and a 1. So what I'm left with is 9 over negative 4. Negative 9/4, negative 2 and a 4th. Same thing. Next up, there's no pluses or minuses, so nothing is linked together. I'm going to actually, I am. I'm going to put all the numerators together. You could start canceling if you want, but before I personally do that, I'm going to put all the numerators together. So my numerator is 10. I have an x to the 4th. I'm looking at a y squared and a y to the 5th. That means there's 7 y's up there. And then I've got my z. A z alone is the same as a z to the 1. I'm going to put a 1 up there so I don't forget that. Now I'm going to put the denominators together. I'm multiplying these across. So 3 times 4 is 12. X times x is x squared. Y squared times y is y cubed. And then I've got my z. Z is the same as z to the 1. Now I'm going to cancel from here. So 10 over 12 would be 5 over 6. X to the 4 over x squared would be an x squared on top. 7 y's on top, 3 on the bottom. There's 4 left on top. Z's, goodbye. So my final answer here is 5 x squared y to the 4 all over 6. Now, we're not asked here to list the exclusions, but from yesterday, I'm expecting that you are a master of exclusions. So if you do get a solution in the future that is an exclusion, you need to make sure you omit that. Okay, 3m over 6 is the same thing as 3m over 6. Did I just say over 6? 3m plus 6 is the same as 3m plus 6 over 1. So the first step is to factor. I'm going to take a 3 out of this, and we're left with m plus 2. So I'm not going to look at that anymore. All right, in the denominator here, 2 numbers that multiply to give negative 12, that add to give negative 4. Remember your diamond puzzle? That would be negative 6 and positive 2. So my factored form here is m minus 6, m plus 2. I'm no longer looking at that. So my numerator, I have an m minus 5. That doesn't cancel. I have this whole m plus 2. That whole m plus 2 can cancel. So nothing else cancels. I'm left with, on the numerator, I've got that 3 and the m minus 5. In the denominator, I have an m minus 6. Nothing more can cancel. Remember, an m minus 6 only cancels with an m minus 6. An m minus 5 only cancels with an m minus 5. The minute you have pluses and negatives, those are bound together. First step, factor. I have a binomial, 2 terms. I'm going to take out the greatest common factor. If I go back up to the top, 2 numbers that multiply to give 16, that add to give 8 are 4 and 4. You could also look at that as perfect squares. And in the denominator, 2 numbers that multiply to give negative 10, that add to give negative 3 are negative 5 and positive 2. If you need more time factoring, just take your time and make those diamond puzzles. Now I'm going to start canceling. This entire n minus 5 can go with this n minus 5. Goodbye to you. And this entire n plus 4 can go with the 1 on the bottom. So my numerator, I have an n plus 4 left on top. Again, that's linked. That's a plus sign. And my n plus 4 can only cancel with an n plus 4. In the denominator, I have an n and an n plus 2. That's my simplified form. Nothing else can cancel. I am done. Greatest common factor of the binomial here, that would be p times p plus 2. Factored. In the numerator, I just factored that right here. N minus 5 times n plus 2. P squared plus 16, that's not factorable. If I had p squared minus 16, that'd be p plus 4, p minus 4. That gives me p squared minus 16, but remember that has to be a minus. This is not factorable. That's prime, so that just stays just like that. So I'm going to start canceling here. I have an n plus 2 I can cancel, and that is it. So in my numerator, p plus 4, n minus 5. And in my denominator, I have a p, and then I have that p squared plus 16, which is linked with the plus sign. Nothing more can cancel. All right, now we have the division. In division, we're going to multiply by the reciprocal, just like we did on that very first exercise. Change this to multiplication and flip the fraction behind it. So, nothing can really cancel. So the whole numerator is 3 times x minus 5. Because of that minus sign, I am going to link this together. An x minus 5 can only cancel with another x minus 5. In the denominator, I have an x to the 5th because I have 5 x's down there. This is just so fun. All right. 18vw squared over 6v times flip 2w to the 4th x over 3v squared x to the 4th. There are no pluses or minuses. Nothing is linked here. Anything on top can cancel with anything on the bottom. We could put the top together first and put the bottom together first, or we could start reducing. With the 18 and the 6, I can see right away that a 6 comes out of 18. So that would reduce to a 3 and a 1. And then I see the 3 on top and the 3 on the bottom. I can cancel both of those and make both of those a 1. Now that we have the numbers gone, let's put the letters together. So the whole numerator would be this 2. And typically you do alphabetical order. So U, V, W, X. So V, W, X. So I have 1 V. I have 6 W's, 2 here and 4 here. And I have 1 X. In the denominator, I have 3 V's and 4 X's. Now I'm going to reduce. So 1 V on top, 3 V's on the bottom. That means there's 2 left on the bottoms. 1 X on top, 4 X's on the bottom. That means there's 3 left on the bottom. So my numerator is 2W to the 6th. My denominator is V squared X cubed. That's our answer. And the last one. You know, as I rewrite this, I'm going to go ahead and factor the greatest common factor out of this binomial right here. So I have x times x minus 1 over x plus 2 times, now this is the same thing as that over 1, and that is also factorable. X plus 3, x minus 1. So when I flip that, my numerator is now 1, and my denominator is now x plus 3, x minus 1. Anything with a plus or minus is linked. I'm going to put a parenthesis around that just so I don't forget. X minus 1's cancel. Nothing else cancels. So my entire numerator is x. My entire denominator is that x plus 2 linked, and that x plus 3 linked. You could write this with the denominator distributed out, which would be x squared plus 5x plus 6. That's totally cool, but this is now linked as a trinomial, and that can only cancel with another x squared plus 5x plus 6. So don't go thinking you can cancel like a random x somewhere, because anytime you have a plus, you are linking with a parentheses. You're thinking of that as an entire body, and you cannot just rip something off of that. That stays together and is 1. One trinomial can cancel with another trinomial, but you can factor, and that's how you get the binomials canceling. So I hope that was totally invigorating. and I will see you tomorrow.